It's nice to see everyone together again. So, if you're like me, when you recognize a last name and it's Greek, you get excited, proud, can't wait to meet that person. So, living in the Cleveland area, I was at University Hospital finishing up some treatments that I was going through, and I happened to look on the one panel and saw the Greek name. Got so excited. Not only was I in excellent care at university hospitals, but I felt even better when I knew the head of the Seidman Cancer Center was Dr. Ted Teknos. So Ted is a wonderful doctor, and even more so a beautiful person, because he cares about each and every person that he either treats or comes to know. And I'm so excited because has a wonderful 97, is your dad? 97-year-old dad in Detroit, where Ted's originally from. Loves his Greek roots. And my dad told me I had to say two things, Ted, because I'd be done now, but I do listen to my dad. He says you're an amazing dancer. So tonight, is it tonight, tomorrow night? Tomorrow night, Ted will entertain us with his Greek dancing. And then, more importantly, he has a wonderful wife, Carrie, who put her medical practice on hold to raise their 6 beautiful children. And if you know Ted, he works 23 of 24 hours. So Carrie does have her hands full with taking over the family. So it's my honor, and I'm so proud to introduce to you Dr. Ted Teknos.
I'm sorry, there we go. So that's setting a very high bar, because, it's hard to meet this bar that you're a good dancer. And I kind of feel this way actually addressing this group after listening to Maria and Chris, our OCF students today, and the general's speech and lecture. It's really, these are amazingly hard acts to follow. So I feel incredibly privileged to be here. Your Eminence, thank you for the invitation, and Jim and Paulette and all of you who organized this conference. I'm thrilled to be here. Really, it's a career milestone of mine, so I thank you. So what I'm going to talk about here a little bit is me to talk a little bit about my journey, and I decided to kind of interlace my journey with what I do for a living. I'm a head and neck cancer surgeon. I do reconstructive surgery as well. I do scientific research based on the basic science of head and neck cancer. But now I spend a lot of my time as a hospital administrator and a deputy director of the Case Comprehensive Cancer Center. So how did I get here? So this was me in my first year of medical school. So Patsy, when Patsy saw this, she said she was going to introduce me and say, "Ladies, doesn't this look like every Greek guy your parents set you up with, And that is true. So how did I get to where I am? So, I trace my roots, as many of you do, to my Greek roots. I'm a first-generation Greek American. And my parents came from the Peloponnese, very close to each other, actually. My mother was from Corinthos, and my father was from a little village outside of Nemea. So it was called Daphne. We used to call it Leriza. But that's where my family originated from. My father actually lived in this little village. He never got out of 6th grade. So he wanted to be a priest, and actually his father told him, "You can't go to the priesthood because I need you to work the farm." So he still brings it up now at 97 years of age. And I said, "But if you became a priest, you wouldn't have had me." He's like, "See, even another reason to become a priest." So these are my parents' home, Nemea and Corinthos, and I love visiting there. My father had a very rough upbringing, as did my mother. My mother was one of 5 girls in the family. She was the youngest, and she actually went to college. She became a teacher. So she taught in Thessalia after finishing her education. My dad, on the other hand, worked very hard for the family. So he he told me this story, and I shared this with my kids the other day. When he was 14 years of age, and this is similar to the story that the general told about his father, he used to make charcoal, karvuna, for ovens at the time, and he would travel by mule 3 days by foot to sell these charcoal bricks, basically, and then come back with they would barter so they could have grain to eat post-war. So very, very rough and certainly a deprived childhood. But then when he was 29 years old, his father said to him, "You got to go to America because we need to marry off your sister, and she needs a prika. We got nothing." So they sent him to the United States at age 29 years of age. This is the ship, actually, he came on. It was the Queen Frederica, and a lot of Greeks, I think, recognize this ship. And I think this was, part of the North American and Hellenic line that would transport a lot of Greeks. It was a small ship. If you look at the bottom here, and I don't know if this is showing, is my pointer showing? But anyway, it's not very big. And that thing crossing the ocean took about 2 weeks, and he was deathly ill on his way. And then I always ask him, I'm like, why did you end up in Detroit? That's where I grew up. And couldn't you go to California or Florida or someplace else? And he's like, no. He goes, that's where I had a job. So his uncle from Greece had gotten him a job at General Motors. And he started out in the upper left there working on the railroads. So he would work on the railroads, very rough work. And the funny thing that happened there is all the people he worked with spoke Spanish. So he thought that was English. So he'd speak to these guys, and then he'd go to a restaurant, and he'd order in Spanish. They'd be like, what is this guy? And then he'd go talk to his uncle, whose wife was American. And he'd talk to her, and she's like, this guy's got problems. I don't understand what he's... But he was mixing Spanish and English, so... My uncle still is convinced he dated a lot of Spanish and Mexican women while he was... before he met my mother. But nonetheless... He moved up the ranks, if you will, at General Motors. He went from working on the railroads to working in the power plant to ultimately becoming a welder, which was the job he held for many, many years before he retired 37 years later. But the amazing thing, and this is also something that the general mentioned, is for 8 years he lived in a rooming house. So, there was cheaper rent. That's where he could essentially help take care of the house, and he could stay there for much lower rent. And a lot of the Greeks who came together at that time would stay at this particular rooming house. Then in 1964, he met my mother. So this is my parents' wedding photo. My mother came over to visit her sister, and they met each other and then ultimately got married. This was the first place we lived, an apartment building. And then this was, in the back here, I always laugh because this car, I remember, was stolen from this alley here. We got it back, and we found out that it was just a couple of kids joyriding, but, it's the challenges of living in Detroit. And then this is my brother, so I have a younger brother as well, Athanasios, who I'll talk about in a little bit. Always, though, and I think like most of us, it was all about our faith and our family. No matter what, our decisions were always driven by those two factors. And this just shows us my uncle Dimitri, who is like a second father to me, as well as my cousins. And this is our first home. And this is our first new car, which we bought in 1971. I think I drove it till I was 30 years old because we never got rid of any cars or anything when we were young. But one thing, and this wasn't just my parents, but it was the entire Greek community. It was an unyielding pursuit of education. They would always say, you need to go to college. And everybody that I touched base with, even people whose restaurants I worked in, they'd say, like, you are going to college, don't even think about it. If you don't, you're out of the Greek community. It's like, wow, pretty serious. So this is my elementary school, my middle school, and public high school that I went to. My high school was a tremendous high school, but I put this picture here. Anybody recognize this whale? So the most famous graduate of my high school was this guy named Weiland, who paints whales on the sides of buildings. And he's a world-famous artist, and And he used to paint vans across the street for me. My dad always used to say, see that guy? I never want you to end up like that guy painting vans across the street. But he's a world-famous multi-millionaire artist. But again, my father, the other thing my family used to always say, I don't care how smart you are, if you don't work hard, you're nothing. Literally, you're nothing if you don't work hard. So I started working when I was 12, delivering papers. And then when I was in high school, a great job one of my buddies found was stacking bricks. So this reclaiming bricks project. So this is 1,000 bricks. So the two of us would stack 1,000 bricks and we'd get $7. So that wasn't very good. But, and then I worked in, if anybody knows Detroit, all the party stores, as they're called, are owned by Chaldeans. So my neighbors were Chaldeans, so I worked in this party store. We got held up a couple of times when I was there. And then Denny's, and of course the obligatory, you got to work as a busboy or a waiter in Greektown in Detroit. So I did that as well. But then ultimately I caught the luckiest break of my life. So the luckiest break of my life was when I was in high school, and I was really enamored by science and math, and I applied to this program where you could spend a summer in a hospital. And I thought that would be something cool to try, so I applied for this internship. They called it an externship at the time. And I got it. I was one of 3 students that were selected. I had to go through an interview process, and it was the first time in my life where I felt like, wow, I can actually accomplish some really cool things. So I worked in this hospital, then I got a job. I got a job my senior year in high school, and I was a phlebotomist. So you guys may know, that means you draw blood. So I drew blood. Everybody called me a vampire. Oh, here comes the vampire. But that really got me a lot of experience, in the hospital setting. Then finally, when I went to college, this Greek influence in my life remained. The only guy who I ever knew, and I decided when I was in the hospital that I wanted to become a physician. The only guy I knew was my good friend Gus. Of course, it's either George, Gus, or Nick. But Gus had gone to college, and he was applying for medical school, and I followed him. I mean, we couldn't afford college, so I had a scholarship to go to Wayne State University in Detroit. And my friend said, I work in this research lab. I think you'd like this guy. His name is Dr. Dutta. So I did. I went and I started working for him. And that's where I got my, the bug to do research. He wasn't doing cancer research per se, but, he got me involved in research, and it was really a life-changing event for me. Then it was time for me to apply to medical school, and I had lots of good friends who were applying at the same time. And I remember I was lucky that that I had gotten accepted to the University of Michigan, which kind of was my dream school at the time. But I had applied widely. University of Chicago, too, actually. That was another one that I was considering going to. But I had gotten an application to Harvard Medical School, and I wasn't going to fill it out. I actually got it. I paid $50. And this guy, who was my good friend in college, Pardeep Rahal, said, what do you got to lose? You already spent the $50. So I filled it out, and a miracle happened. I got in. So I'm convinced that if you remember that first picture, that they thought I was a different race than I really was. That's why I got in. But I think I earned my keep. Yeah, that's right. So I spent 4 years at Harvard Medical School, and it was an amazing, amazing experience. Like the general says, it's because you have to up your game because of the people who are around you. And that's what happened. So these are my roommates. As you can see, we're like the United Nations, Indian guy, a guy from Taiwan, a Jewish African-American guy, and me. But these were my teachers. So my teachers were, this person will win a Nobel Prize one day. His name is Judah Folkman. And then these other folks who really inspired me. And my classmates were no slouches. This guy in the middle here, upper right, right in the middle, his name is Jim Kim. He was the head of the Partners for Health, which basically saved Africa from AIDS. So he started that with Paul Farmer. And then this buddy of mine was the president of CVS Minute Clinic. And this person, who I'll come to later, invented CRISPR-Cas editing, which is gene editing that can be used used to treat diseases. He was my classmate. The funny thing about him, though, is he didn't know that a prostate was only in men. So he discovered this, but he made that mistake once on an oral exam. Finished graduation, as like with all Greek families, we brought like the entire universe to graduation. So parents, uncles, cousins, everybody was thrilled, obviously. So, and then I took a trip to Greece that summer with my grandfather here in the bottom. These are all the Theodores in the family. So every child who had a male named him Theodoros. But we had a wonderful time. And then what happened, which was really kind of interesting and really convinced me that there is a plan in life, is that I didn't get to go to the place where I really wanted to be trained as an otolaryngologist. I really wanted to go home to the University of Michigan and be by my family and go to the church that I was used to going to. But I didn't match there. Now, you can say, oh, where did you match? Well, I stayed at Harvard, so it's not exactly a bad plan B. But I was devastated that I couldn't go back and be home with my family. But there is a plan in God's plans for us. This gentleman in the lower left, Mark Vivaris, he's now the chairman of that department. He became my best friend. This person in the middle, Dr. Montgomery, was one of the giants in the field of otolaryngology, who was my mentor. And then this guy on the lower right, he was my fellow at Mass Eye and Ear, and he's now my CEO at University Hospitals in Cleveland. And he recruited me to come to Cleveland. So there was a plan, but the real plan was for me to meet my wife. I met the love of my life there. And that was the plan. All the other stuff is gravy, but the plan was for us to meet and have our 6 beautiful children. Then I went home. That's the other fun part about it, is when I graduated, I actually went back and I started a research career in cancer research. And these were my mentors there. I study head and neck cancer, HPV-related head and neck cancer specifically, and how that comes, and had a very successful and thrilling career studying that. And certainly it probably pales in comparison to Leon's research, but certainly something that I'm very proud of. Then for those Buckeyes in the room, I got recruited from University of Michigan to go to Ohio State. So that's where I first learned how to be a leader, how to lead a large organization. And then finally, I had, this is in the upper picture there, that's my aunt, and her husband, who's my uncle, that's sitting next to my father here. Both of them died within a couple of years of cancer. My uncle had small cell lung cancer, and my aunt had the BRCA mutation, which some of you may have heard of, and she first had breast cancer, but then ultimately succumbed to pancreatic cancer. So I wanted, even though I was really focused on research in my specialty in head and neck, I wanted to broaden my horizons and do more for cancer patients. So that's when University Hospitals came calling, and I always pray to God to give me guidance on whether or not I should take a job or not. And he guided me in every step of my way. And in this job, I did the same thing. I prayed. And then one thing that really came to me one day as I was praying to him is University Hospitals is located on Euclid Avenue in Cleveland, Ohio. My father, this boarding house, was on Euclid Avenue in Detroit. So the full circle of my life basically came from and led back to Euclid Avenue. So I moved to Cleveland, and that's sort of my story. Now, how does that have anything to do with the Cancer Odyssey? I want to talk a little bit about what's happened in cancer from the time my father was born and from the time I entered medicine to today. So, in honor of the general, I want to, if we could start this video.
The 20th century was all about physics. It was all about Albert Einstein and creating the atomic bomb, detonating the atomic bomb, and all that sort of thing. I think the 21st century, actually late 20th century, is all about biology. So we've changed our focus as a culture. As creative individuals, we look at either experiments in nature or accidents and learn from things. During the First World War, one side was trying to kill the other side with this toxic gas called mustard gas.
One of the Army Medical Corps officers was taking care of some of these survivors of gas attacks, collecting blood samples. And when he came back to the United States, he published an article that observed the dip in white blood cell count, the bone marrow suppression.
Nitrogen mustard wiped out people's bone marrows. So the thought was, let's use lower doses of it and make it less toxic to wipe out the abnormal bone marrows of people who have leukemias and lymphomas.
In 1942, an Allied ship was docked in the harbor of a town called Bari in Italy. There was a shipment of mustard gas being stored in tanks. When the Germans bombed the harbor, the ship exploded and the mustard gas went into the water. This was a tragedy, of course, and it was an embarrassment for the Allies. And so the public health consequences were taken seriously. And the same bone marrow suppression, this dip in blood cell counts, was noticed again.
Mustard gas actually was the forerunner of being able to start to poison not the person, but poison the cancer.
One of the first humans who received that as a chemotherapy for a known cancer was Babe Ruth. And when he spoke in his farewell address at Yankee Stadium, he was actually being treated with chemotherapy agent for a malignancy. He had a response for about 6 months, and then, his tumor came back and ultimately took his life.
There was no sort of great system for disseminating knowledge. So there were some networks created by the government to fund and organize medical research and scientific research, and get scientists talking to each other, get the resources and knowledge that they needed available to solve problems faster.
Particularly, there was the use and the concept of combining chemotherapies. Scientists started figuring that if one worked on part of the cancer and another one would work on another part of the cancer, that together there would be stronger responses. And that indeed was the case. So starting in the 60s, this concept of combination chemotherapy came into vogue.
It's the first time that they're trying multiple drugs together. And so Rayrick and Frey had fantastic results. So it seemed really promising. And then months later, years later, after that initial trial, they did eventually die of their cancer. Every major exciting step forward, there's more problems to solve.
Survival rates for cancer of all kind at all stages at that time was about 56%. It was bad news. So there was a lot of changes that occurred around that time.
We are here today for the purpose of signing the Cancer Act of 1971. And I hope that in the years ahead, that we may look back on this day and this action as being the most significant action taken during this administration. It could be, because when we consider what cancer does each year in the United States, we find that more people each year die of cancer in the United States than all the Americans who lost their lives in World War II. This shows us what is at stake.
So that Cancer Act went into effect in 1971. And right up until that time, there were a few successes, if you will, in cancer care. Single-agent chemotherapy really only cured one adult cancer. It was a choriocarcinoma, a very rare tumor. And then combinations were making great inroads for children's leukemias and lymphomas. But by the time I started medical school, chemotherapy was really seen as a way to extend life and not necessarily to cure people of their cancers. And, to be perfectly frank, a lot of the reason why I chose to go into surgery was because you could make this impact in early stage cancers and really be able to cure them in a surgical way. But as we as human beings learned, there are other things that our bodies tell us. So the major breakthrough that really occurred dated back to 1954. So this is when Watson and Crick discovered the DNA molecule. So this, I love this picture because this was on the cover of Life magazine. And look at this picture. I mean, they're like in a basement and there's like pipes all over the place. Oh, sorry. You imagine putting that on the cover of Life magazine today. But this was the first model of what's called a twisted ladder, or the DNA double helix. And each of these is a base pair. So these individuals discovered DNA. That's the blueprint for life. And people then started isolating this and purifying it and starting to sequence it. And the first sequence that occurred was actually in 1974. So 20 years later, somebody sequenced the first gene, and it was in a bacterial virus. So not entirely humanly pertainable, but it took a long time. And then 8 years later, the Epstein-Barr virus's entire genome was sequenced. It took 8 years, and it was only 72 genes and 172,000 base pairs. So this guy, Crick, called all these scientists together at Cold Spring Harbor in Maine and said, you know what, we got to make the government pay to sequence the human genome. So he got together, with all these scientists, they wrote a letter, and they sent it to Congress and to the president to create a human genome project. Well, that time there was no automation, and it took 8 years to sequence 72 genes, so it would have taken 1,000 years to sequence the genome. So that was rejected, but then as happened about a year later, an automatic sequencer was invented by Frederick Sanger, and then they tried again to get this Human Genome Project funded, and it worked this time. So in 1988, President Reagan put it in his budget, and it was supposed to last 15 years, and it was supposed to cost $16 million. Well, they did it in 13 years, but it cost $3 billion. So a little over budget, but they did it quickly. And that really is what set off this revolution. And the first drug that was discovered really while this was happening was a drug called Gleevec. So this is a drug that was used from genetic sequencing to turn off a gene in this chronic myelogenous leukemia, and then allow people to have much, much better outcomes with less toxicity using these targeted agents based on their DNA. And then in 2003, the Human Genome Project was published. So that drug was developed in 97. Human Genome Project, which had 22,300 genes in it. That's how many genes we have. Was published in 2003. Then in 2006, they published all the genes that are associated with different cancers. And the amazing thing about this is, to date, only about 291 genes have been found to be associated with malignancy. So less than 1% of our genome is what causes cancers. And we're trying hard, as you'll hear, to turn these off. What else is amazing is that it used to cost billions and decades to sequence a human genome, but through innovation, it now takes 2 hours to sequence a human genome, and it costs about $500. So it's a very different, and the speed of discovery here is remarkable. And I'll leave you with the fact that this gentleman, who is an orthopedic surgeon, discovered that if you injected bacteria, or at least products of bacteria, into a tumor, the immune system started to identify the tumor and attack it. So this is a patient who had no treatment, no surgery, no radiation, but had bacterial elements injected into his tumor. Then he had this response. Dr. Coley called this Coley's toxin. So this was the first attempts at immunotherapy. But what the Human Genome Project taught us is that cancer cells produce this protein that knocks out the immune system and doesn't allow it to recognize tumors. And then about almost 10 years ago now, a scientist at MD Anderson, Jim Allison, discovered if you could turn that protein off, the immune system then can identify tumors and start to attack them. And about 20% of patients get these miraculous responses to checkpoint inhibitors where they had very little likelihood to survive, but then 20% have these really remarkable and durable responses. And this is an example of that. This is somebody with mesothelioma, which is a very deadly cancer, was put on a checkpoint inhibitor, and these tumors were gone within 9 months, and the patient still remains free of these tumors 5 years later. So really remarkable results. But what about those patients who you can't, or those 80% who are resistant? What is happening today is actually scientists are training the immune system and taking the cells out of a patient, altering them genetically so that they can recognize a tumor and giving them back to patients. So Dr. Panagos will talk to you likely about malignancies that are hematologic malignancies, and we have some treatments now that target certain products on the surface of leukemias, lymphomas that are remarkably successful. And I'll show you an example of one patient right here. So this is a lady who had a non-Hodgkin's lymphoma. She had what's called a CAR T therapy, and all the black here is cancer. So she was infused with this CAR T, which you can make it commercially. We're fortunate at University Hospitals, and I think Northwestern is similarly fortunate, that we can now alter these things in our own hospital in a very brief period of time. So this was all this cancer that she had, and then about 3 weeks later, it was all gone. So tremendous responses. About 75% of patients can go into remission with these therapies after multiple treatments. The question will be, how durable will they be, and how can we make sure that lasts? And I'll leave you with one final thing, which seems like science fiction, but it's occurring now. So you remember how we talked about there's 291 genes. What if we could actually replace those genes with normal genes? And this friend of mine from medical school, the guy who didn't know about prostates, he discovered and developed a company called Editas. So he actually essentially is able to, with the technology that he's created and others, it's not solely his, to cut DNA very precisely and then put normal DNA in its place so that you can exchange a gene that's abnormal and then replace it with a normal gene. There are already clinical trials. His company, and we're one of the centers of excellence at University Hospitals, is already curing sickle cell disease. You know, it's one gene. It's actually a very small defect in a very specific gene. And you can cut that gene out of patients' bone marrow, replace it with a normal gene, and they no longer have sickle cell. Our own culture, thalassemia, is another one that they're targeting for cures as well with this. So I leave you with this, and I'll turn it over to my friend Leon. For 3,000 years, not much, occurred. We'd cauterize tumors. We would, do all kinds of crazy things as humanity. But then in 1900, radiation was invented, and that was a big leap forward for cancer care. Then chemotherapy was invented really by accident, as you saw. And now the Human Genome Project has allowed us to do these targeted therapies and these new checkpoint inhibitors. So the future has never been brighter for cures for cancer. 586,000 Americans die every year of cancer. 450,000 died in World War I. So we lose the equivalent of World War I every year. But never has there been a time in our history where we're closer to getting a cure to cancer. And I think we'll see many cures during our lifetimes, I have no doubt. And with that, I thank you for your attention. I thank His Eminence and Leadership 100 for the opportunity.